Okay, so now we're starting number 16 on the end of course review. So these are asking us to factor, which are the things that we did at the very beginning of the school year in our review of factoring unit. So we have kind of a couple different things happening. The first one is a quadratic when A isn't 1. So remember, when A isn't 1, we're using the star method or a product sum chart where we have to multiply A times B. So 10 times -3 gives us -30. And so that goes in the product area. And then in the sum area, we need two factors that add to -13. And so notice that 10 and -3 won't work. 10 plus -3 is +7. So that means that what will work though is -15 and +2. So -15 and +2 are going to add to -30, and then multiply to -30 and add to -13. So about 10x minus 15 and 10x plus 2. Remember, the big idea here is we have to be able to simplify those, at least one of them, because 10x times 10x makes 100x squared, not 10x squared. And so notice that if we do simplify this, we can divide the first one by 5, right? So if I divide this by 5, I get a 2x minus 3. And so if I divide that by 5, I get 2x minus 3. And then if I go ahead and divide the other one by 2, then I get a 5x plus 1. So you always want to kind of double check at least, does 5x times 2x make 10x squared, and does -3 times +1 make -3? So that's factoring when A isn't 1. For B, it's a difference of cubes. And so this is the form A cubed minus B cubed, and that works with the pattern A minus B. Plus A minus B times A squared plus AB plus B squared. And so remember that if that was a plus instead, what would change is that these two would switch. So it would be plus here, minus here, plus here always. And remember, we had the acronym SOAP, same, opposite, always positive. So the first one's the same. So the A minus B is A minus B because it was A cubed minus B cubed. Then the opposite of that was positive, and then the last one's always positive. So looking at this, if this is A cubed, then I take the cube root of 8x cubed, which tells me that A is 2x. And then I take the cube root of 27, which tells me that B is 3. So then if we plug in 2x for A and 3 for B, we've got 2x minus 3. And then 2x squared is 4x squared. And then plus, we're multiplying these two together. So 2x times 3 is 6x. Plus B is 3, B squared is 9. So that means that 2x minus 3 times 4x squared plus 6x plus 9 is the factorization of 8x cubed minus 27. For C, we have a quartic function. But we actually factor this the same way as we would factor a quadratic, except for one thing. So if I was doing like a product sum with this, I would just put x. If it was a quadratic, since it's a quartic, I'm going to put x squared. So I'm still looking for a product sum or using the magic x to see what, since A is 1, multiplies to 12 and adds to -7. And so thinking about that, our two numbers are -4, -4 and -3. So -4 times -3 is +12, and -4 plus 3 is -7. However, when it's a perfect like this, we actually have to look at our factors and see if they're factorable. Usually it's going to be a difference of squares. And so x squared minus 3, 3 is not a perfect square, so I know that that's just going to stay how it is. But x squared minus 4 is a perfect square, so that's going to be a difference of squares where the square root of 4 is 2. So that's going to be x minus 2 times x plus 2. So the complete factorization of this guy is x squared minus 3 times x minus 2 times x plus 2. The last type of factoring that we saw was factoring by grouping. And so we're looking at this as two separate groups. And remember, we factor out a GCF. So if I'm looking at just 2x cubed minus 3x squared, the only thing they have in common is the x's, because 2 and 3 have no common factors except for 1. So I can take out x to that lowest power, which is squared here. And so if I divide, remember 2x cubed by x squared, I would need a 2x. And then if I divide out the x squared here, I would have a minus 3. And so remember that when we factor by grouping our second group, what's inside the parentheses should be exactly the same. And so notice that 2x and 3 have nothing in common. It's almost what we have here. And so what we actually have to do is factor out that negative 1. So I need to make this factor out the negative, then the 2x is positive, and then the 3 turns negative. And so then remember that they share this 2x minus 3. So I'm going to factor that out. And when I factor that out, I'm just left with a coefficient. So I'm left with x squared minus 1. Okay. And so looking at this one now, just like our x squared minus 4, 1's a perfect square. So that means this is going to factor to be 2x minus 3 times x plus 1 times x minus 1. Okay, so the full factorization of this guy looks like that. Okay, so then for number 17, quotient means division. Remember that when I have something that is linear like this with x plus or minus a number, I can use synthetic division. For the sake of space, I'm going to use synthetic division here. Remember that you could use long division. So with synthetic division, I just write out the coefficients. And so that's 4, 3, 6, and 1. And then I do the 0 of the divisor. And so the 0 of this is negative 3. And so I'm going to put the negative 3 on the outside. Remember that the process for synthetic is I bring down the first number and then I multiply. So negative 3 times 4 is negative 12. I add that with 3. So negative 12 plus 3 gives me negative 9. And then negative 9 times negative 3 gives me positive 27. And then 27 plus 6 gives me 33. So this is getting kind of large. Negative 3 times positive 33 gives us negative 99. And so negative 99 plus 1 gives us negative 98. So remember, the way that division works is if I was actually dividing, I would be bringing down the power by 1. So since this power here is a 3, when I write out my quotient, it's always going to be 1 less for the first one. So the coefficient on a 4 is going to be for x squared. So 4x squared, and then minus 9x plus 33. And then our remainder is negative 98. Remember, we write that over our divisor, so over the x plus 3. So that's our quotient. For number 18, we're looking at finding the difference of two fractions. We can only subtract fractions if they have the same denominator. So we need to make a common denominator. So I'm going to rewrite the problem, and then we'll multiply by something to get common denominators. So x plus 5 and x minus 4 are totally different. So that means that I have to multiply each fraction by the other one's denominator. So I'm going to multiply this first one by x minus 4 over x minus 4. I'm going to multiply the second one by x plus 5 over x plus 5. So when I do this, I don't have to multiply out the denominator. I'm just going to leave it as x minus 4 times x plus 5. So they share the same common denominator now. What I am going to do, though, is multiply out the numerator. So if I have 2x times x, that gives me 2x squared. And then 2x times negative 4 gives me minus 8x. Next, I have this minus 2, so I'm going to use the negative. So negative 2 times x is minus 2x, and negative 2 times 5 gives us negative 10. And so what we end up with then is 2x squared minus 10x minus 10 over x minus 4 times x plus 5. And so what I want to check now is, can I factor that numerator? So since it has an a of not 1, I would have to use the star. So if I double check this, 10 times 2 is so negative 20, and then add, excuse me, to negative 10. And so my factors of 20 are 2 and 10, and 4 and 5. And so notice none of those, that adds to 12. Oh, actually, they'd have to be opposite. So it would be negative 8 and negative 1. So that means that that's not factorable. So this is just our answer. For 19, we're finding a probability. We're rolling 2 number cubes, so a die. Those have the numbers 1 through 6 on them. And so when it's and probability, that means we're multiplying. So we're finding the probability that we get a 5 and the probability we get a number less than 2. And so since each die has 6 sides, we want to identify how many 5s are on a die and how many numbers less than 2 are on a die. So there's only 1 5 on the die, so that probability for the first one is going to be 1 in 6. And then there's actually also only 1 number that's less than 2 on the die, so that 1 is also giving us a probability of 1 in 6. And so to do this, we're multiplying. Remember, to multiply fractions, you multiply straight across. So 1 times 1 gives us 1. 6 times 6 gives us 36. So our probability of rolling 5 and a number less than 2 is 1 in 36. Okay, so for these next problems, we're going to need the unit circle. So first, we're going to find sine. Remember, sine is the y coordinate and cosine is the x coordinate. So to do this, because our unit circle only goes to 360, we're going to subtract 360 from each of these. So this tells us, is that really asking us something that's equivalent to sine of 120 degrees? And then for the second one, if we subtract 360, they're really asking us what is cosine of 240 degrees. And then let me scroll down to the unit circle and see if we can read this well enough to answer, or if I need to get another one. So 120 is here, and sine is the y coordinate. So that means radical 3 over 2 is going to be our answer. And then 240 is here, and cosine is our x coordinate. So that means negative 1/2 is going to be our answer. So for the part A, it's radical 3 over 2. And for part B, it's negative 1/2. For 22, they're asking us for sine, cosine, tangent, cotangent, cosecant, and secant. I'm going to write these out with just sine and cosine and tangent with their acronym. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. And so looking at where theta is, this is opposite, this is adjacent, and this is hypotenuse. So just using the triangle we have, we can tell what cosine is. That's going to be 8 over 17. We also then can tell its reciprocal secant is 17 over 8. Remember the reciprocal sign is cosecant, and the reciprocal, oh, an answer there. And the reciprocal of tangent is cotangent. Okay, so what we need to do in order to answer this question for the rest of these is we need to figure out what the opposite side is because we don't know it. So to do that, we need to use the Pythagorean theorem. So I'm going to call this x for now. So x squared plus 8 squared is equal to 17 squared. So x squared plus 64 is equal to 289. And so then, I'm just double checking that that's 17. 17 times 17 is correct, 289. So then if I subtract 64 from both sides, so then if we subtract 64 from both sides, that gives us x squared equals 225. So if we square root that, that's 15. So that means that this opposite side is 15. So that means sine is opposite over hypotenuse, so 15 over 17. So then cosecant is its reciprocal, 17 over 15. And then tangent is 15 over 8, which means cotangent is its reciprocal, 8 over 15. And that's all 6 of the trig function. For number 23, we're looking at a 30, 60, 90 right triangle. So remember that the patterns are all related to the shorter side. So if this angle is 60, that means this one's 30. And the side opposite is what we always call x. Okay, so this is x. And then the longer leg is x rad 3, and the hypotenuse is 2x. So if I want to solve for x, I have one equation that I can use because this tells me x equals x and y equals 2y. So all I can use is the idea that x rad 3 is equal to 12 centimeters. And so I can divide both sides by rad 3, which tells me x equals 12 over rad 3. But that's not going to be an answer choice for you. So what you have to do is rationalize the denominator, which means I'm going to multiply by rad 3 over rad 3. So that gives me 12 rad 3 over 3, which actually I can simplify because 12 divided by 3 is 4. Okay, so I've got x. So x equals 4 rad 3. Also asking for y. Y we can see is just 2x. So y equals 2 times that 4 rad 3, which means 2 times 4 is 8, so it's 8 radical 3. For number 24, we are using the unit circle again. So they're giving us different things, either in degrees or radians. We don't have to do any math to find the value on the unit circle. We just have to use the unit circle. So remember that tangent is y over x, which means cotangent is x over y. Cosecant is 1 over y, which remember means reciprocal. So it doesn't mean I'm going to write 1 divided by whatever y is. It's a fraction already. I'm just going to flip it. Same thing with secant. It's technically 1 over x, but that really just means that it's the reciprocal of x. So let's look for 11 pi over 6 on our unit circle. So 11 pi over 6 is this value here. So our x is rad 3 over 2. Our y is negative 1/2. So we're going to use those two values to simplify and tangent, to find tangent. So y was negative 1/2. X was positive rad 3 over 2. Remember that since they have the same denominator, we can cancel out the denominator. So we really have negative 1 over radical 3. However, just like in the last problem, we can't leave it like that. We have to multiply by rad 3 over rad 3, which means this is equal to negative radical 3 over 3. B, we're looking for tangent of 2 pi over 3. So 2 pi over 3 tells us oh, that's the one that we used for 120. So it's negative 1/2 and then positive rad 3 over 2. So we're going to do rad 3 over 2 over negative 1/2. This one's a little nicer than that one because when it cancels, the radical's on top. So we get rad 3 over negative 1, which is just negative radical 3. Cotangent of 5 pi over 4. The good thing about pi over 4s is that x and y are actually always the same number. They're just opposite signs. So if I look at where 5 pi over 4 is, that's here, 225. And so it's negative radical 2 over negative radical 2. And so when I divide that, I'm dividing something by itself, right? So it's negative radical 2 over 2 is my y, and negative radical 2 over 2 is my x, which means I technically have negative 1 over negative 1, which is just positive 1. The last two are going to be a little bit easier because it's just the reciprocals of one thing. So we only have to know y for 240, and we only have to know x for 150 in order to find cosecant or secant. So let's look for 240 and 150 kind of at the same time, because then we can just remember two numbers. Okay, so 240, we needed the y value. The y value of 240 is negative rad 3 over 2. And I already forgot the other number, so I guess we're only going to do that one. So negative rad 3 over 2 is the y. So the y is negative rad 3 over 2, which means that the reciprocal of y is negative 2 over rad 3. So for this one, we have to rationalize. So we multiply by rad 3 over rad 3. We get negative 2 rad 3 over 3. So that's our answer there. Then we need 150. We just need the x coordinate there. So 150 is, the x coordinate is negative rad 3 over 2. And notice that's the same as what we just had. So that means that our answer is going to be the same. So this is also negative 2 rad 3 over 3. Okay, so moving on. Number 25. Jane walked 20 feet away from the entrance to the school's football field. She looks up at a 70-degree angle and sees a flagpole. How high up is the top of the flagpole? So she's looking at the top of a flagpole at a 70-degree angle from 20 feet away. We want to know this side. What we want to think about then is SOHCAHTOA. So notice that x is opposite of 70 and 20 is adjacent, right? Our hypotenuse is not relevant to the problem. So the trig function that we're going to use is the one with opposite and adjacent. That's tangent. So we know tangent of theta equals O over A. So then in our case here, tangent of 70 equals x over 20. And so to get x by itself, what we want to do is multiply both sides by 20. And so then x is going to be equal to 20 times tangent of 70. Again, double check that you're in degree mode, just in case something got changed. So tangent of 70 times 20 is about 54.9 feet. Just double check. Yeah, okay. 26 and 27, we're converting from degrees to radians and radians to degrees. When we're converting from degrees to radians, we're using the ratio pi over 180 as a equivalent to 1, because 180 and pi are radian and degree equivalents. When we're doing the opposite, we're going to use the reciprocal. So we're going to do 180 over pi for 27. A way that you can tell is the denominator should cancel your units if you're in degrees and the pi if you're in radians. So if I do this 200 degrees times pi over 180 degrees, as I simplify this, I can cancel out my degrees. Similarly, since they both end in a 0, I can divide them by 10. And so I'm left with 20 pi over 18 And then I want to simplify that if I can, and since these are both even, I can at least divide by 2. I want to see if there's anything else. So if I divide them by 2, this is 10 pi, and 18 is 9, and 10 and 9 don't have any common factors. So that's 10 pi over 9 right here. For 27, we're going to take the negative 7 pi over 2 times 180 degrees over pi. And notice the first thing that we should be able to do is to cancel out the pi. Otherwise, we don't have the right formula. So then if I divide 180 by 2, that gives me 90. So really, I have negative 7 times 90 degrees. And that's going to give me my value for the degree answer. So that's negative, it's not 360, 630. Negative 630 degrees. For 28, we're looking for the angle that makes sine equal to negative rad 2 over 2. So remember that for sine, we're only looking in quadrant 1 or quadrant 4. Same thing for tangent. For cosine, it's different. We're looking in quadrants 1 and quadrant 2. So there should only be one answer to this, one positive or one negative. So since we're looking for y to be negative rad 2 over 2 in quadrant 4 or 1, we're only looking at this half of the unit circle. And so that's here. So our answer is 7 pi over 4 for number 27. Cosine is x, so we're looking in quadrants 1 and 2 for cosine to be rad 3 over 2. So we're just looking in the top half here for it to be positive rad 3 over 2, which is here. So our answer there is pi over 6. For tangent, remember, since it's y over x, we're looking for it to be the same number, but opposite signs. And so what I know is, I know it's going to be something over 4, because that's where that occurs, where I have rad 2 over 2 for both x and y. I just need to know what pi over 4 it is for it to be negative 1 in quadrants 1 and 4. So if I look at quadrants 1 and 4, so notice I have pi over 4, they're both positive, so that would be positive 1. Here at 7 pi over 4 again, it's going to be negative 1 because I'm negative over a positive. So this answer is also 7 pi over 4. For 29, we have to solve for sine, and then we're going to use the unit circle to find our answer. So since I have a sine theta by itself on one side and then a constant with another sine theta over here, I'm going to subtract sine theta from both sides, which gives me 1 equals negative 2 sine theta. And so then if I divide both sides by negative 2, that gives me that sine theta is equal to negative 1/2. So that means that I want to look on the unit circle to see when y is equal to negative 1/2. For these, I should have 2 answers. Okay, so I'm going to have 2 answers for this. So looking at my y coordinates for negative 1/2, I know it's going to be on the bottom half of the unit circle because y is negative there. So y is negative 1/2 at 210, but remember I want to use radians, so 7 pi over 6. And then it's also negative 1/2 here, so 11 pi over 6. So our 2 answers are 7 pi over 6 and 11 pi over 6. Okay, so then the last problem for today is giving us a triangle. They want us to do 2 things to solve for side A and to solve for the area. So when I'm given 3 different letters, I know I'm going to use the law of cosine. And what dictates which one I'm going to use is essentially what I'm looking for. So since I'm looking for side A, I'm going to use the formula that is solved for side A. So I'm going to use this one. If they gave me angle B, I would use the next one. If they gave me angle C, I would use the next one. I'm not using the ones below because that's if I don't know an angle, right? So I'm going to use a squared equals b squared plus c squared minus 2 times b times c times cosine of a. So a squared equals b squared plus c squared minus 2 times b times c times cosine of a. So remember that when I do this, I want to literally plug all of that into my calculator and calculate it. So I'm going to type in my 8.5 squared, plus my 10 squared minus 2 times 8.5 times 10 times cosine of 80 and that gives me 142.73, and that's a squared though, so I have to square root it, which gives me that A is about 11.9. For the area, I'm going to use the formula 1/2 B times B times sine of A. Depending on what they give you, like for example, on your test, if it was a capital B instead, the B and the A would just switch. So it's always half of the product of the sides times sine of the angle. So we're going to do 1/2 of 8.5 times 10 times sine of 80. And remember when we learned this, I kind of talked to you about it's good to simplify that 1/2 with something so you don't have to type in as much. So if I do 8.5 times 5 instead of 1/2 times 10, that gives me a little bit less to plug into my calculator. So that gives me about 41.9 square units.